Hello learners, I Alok Kumar Gupta, Academic Officer Physics, welcome you in the video program of National Institute of Open Schooling. Dear learner, today our topic is units, dimensions and vectors. In this topic we have selected introduction of units. In this lesson you will read about what is units, their standard unit like SI unit of mass, length, time, etc. Also we will discuss about errors like relative error, etc. For this discussion, today our expert is Sri Sher Singh, Principal, Navagi School, Rodhi Road, Delhi. So I welcome Sri Singh sir, please discuss and clear about this topic to our learners.
You know that in today's world nothing is possible without measurement. Whatever you do, whether it is a small work or it is a big work, we always starts with measurement. And for every process of measurement, we need a unit. So first we have to define a unit. For every measurement, we need a standard to compare the given physical quantity. If a given physical quantity is n times the standard physical quantity that we call unit u, then the value of physical quantity will be nu. Here u is the standard and this standard which is used to compare the measurement or which is used to measure the physical quantity by the process of comparing is known as unit. Unit must have some important characteristics like it should be well defined, accessible, convenience in use, universally accepted and it should be invariant. Invariant means it should not change by changing the place, by changing the conditions or by changing the regions. Units are of two types. One is fundamental unit and one is derived unit. And there is a very important system nowadays which is used for the measurement known as International System of Units. In 1971, the International Bureau of Weights and Measurement held its meeting and decided a system of units called International System of Units. It is abbreviated from a French name La System International de Units. It includes fundamental quantities. These fundamental quantities are 7 in number and one is mass, second is length, third is time, fourth is electric current and fifth is temperature, sixth is luminous intensity and seventh is amount of substance that is known as mole.
Sir, is there any category of units?
Yes, there are the units which I have already told you, the fundamental units and derived units, but there are also other practical units and supplementary units. When we say supplementary units, it is radian for angle and it is steradian for solid angle. Practical units you can say light year, slash, sec, parsec. These are the practical units and these units are used for the measurement to make the measurement more and more convenient. If we are taking a large measurement, then we should select large units. If we are taking the small measurements, we should take the smaller units. International system, we have to define certain standards. First, we are taking the standard of length. In 1889, the standard meter was redefined as the distance between two marks engraved on a platinum iridium bar, preserved at a constant temperature of 273.16 Kelvin and at a bar pressure. Bar pressure means 1 atmospheric pressure and it is placed in International Bureau of Weights and Measures in Paris. Since 1966, it is defined in terms of the wavelength of light and it is called atomic standard of length. The meter is the distance containing 1650763.73 wavelength in vacuum of the radiation corresponding to orange red light of krypton 86. But at present meter is defined as the path travelled by light in vacuum in 1 upon 299,792,4583 seconds. Similarly, we define the standard of mass. The standard unit of mass is kilogram. Originally, kilogram was defined as the mass of 1 liter of water at 4 degrees Celsius. Now, the kilogram is the mass of platinum iridium cylinder placed in special vault in the International Bureau of Weight and Measures. Similarly, we can define the standard of time. The standard of time is second and it is also called atomic standard. At present, second is defined as the time interval of 9192631,770 vibrations by radiation corresponding to the transition between two specific hyperfine lines of cesium 133 atoms. Now, to measure the things, very important part is how much accurate we can measure and with what precision. For that, let us take one very simple instrument which you have already seen, and this is a scale which is used for the measurement. Here 1 centimeter distance is divided into 10 equal parts. So, each smaller part is the smallest measurement and the points which coincide with the marks will give the accuracy of the measurement. If it does not coincide with the marks, definitely there is a fault of accuracy. So, the least measurement of this scale is one smaller division, that is of 1 millimeter, or you can say 0.1 centimeter, and it is only the measurement which is accurate. So, the least and accurate measurement we call as least count, and every measuring instrument has least count. So, this is the idea of the least count, and learner, you are very much familiar with this type of scales for the measurement of length of the line and breadth of your notebook, etc., etc. Similarly, we have some complex instrument also, and very popular instrument is vernier calipers. Vernier is the name of scientist who devised it. In vernier calipers we have two scales, and this scale is known as main scale, and here one more scale is here where you can see the very small divisions. This is called vernier scale, and the object whose length is to be measured is placed here, and we can take one object. Here
you can take this one, sir.
We have a glass, we want to measure its external diameter, then we have to keep this instrument like this, very carefully, gently we can press it so that it can touch the external diameter, and also we can measure the internal diameter by using this vernier calipers like this. We can also measure the depth of this container by using this strip. We have to touch the bottom and then this boundary and the bottom. So, this will give you the depth, but again in this measurement we need least count. Here we define the least count as the value of one division on main scale divided by the number of divisions on vernier scale. So, it comes equal to 1 millimeter divided by 10, that is 0.1 millimeter or 0.01 centimeter. And more important thing is this, when we use the object like this, the main scale will give you the reading of main scale. Suppose it is 5.6 And secondly, we have to see the coinciding division of vernier scale with any mark of the main scale. Suppose it comes equal to 6, then we have to multiply it by this 6 to the least count, and that least count is 0.01. So, 0.01 multiplied by 6, it will give 0.06. So, the total measurement becomes equal to the value of measurement by main scale plus value of measurement by vernier scale, that is 5.6 plus 0.06, that is 5.66. Similarly, we have another instrument which is known as screw gauge, and the part which is in my finger grip is known as ratchet. This is circular scale, and here you can see main scale. Here you can see the divisions on the main scale. In similar way, we can define the least count of it, and least count will be the value of one division on the main scale divided by number of divisions on the circular scale. Here value of one division on the main scale is 1 millimeter and number of divisions on the circular scale 100. So, 0.1 centimeter you can say, or 1 millimeter you can say, divided by 100. So, it will give you 0.001 centimeter, that is up to 3 place of decimal. And if you want to measure the thickness of very smaller value, we can keep the object like this, and then when it comes in the grip directly like this, we have to read the main scale and same way the number of divisions on the circular scale. Similarly, its total measurement will be the measurement of main scale plus measurement of circular scale. In circular scale, we have to read the coinciding division, and again we have to multiply these coinciding division to the least count of the instrument, and then we have to add it into the main scale reading, then we will get the complete measurement. So, these are the simple and popular instrument used for the measurement. And now, in all measurements, the important point is the least count. The least count of a measuring device is the smallest and accurate measurement that can be made precisely with it. For example, the 3 clocks are shown here in the figure, and these 3 clocks have least count 15 minutes, 15 seconds and 5 minutes respectively. Now, you can see in first clock the divisions are 15 minutes apart, and it has only the minute hand which can measure the smallest time. So, the smallest time which can be measured accurately by this clock is 15 minutes. In next, we have a second time hand, and again we have 2 marks by 15 seconds apart. That is why its least count is 15 seconds. In next clock, the 2 marks are 5 minutes apart, and the time hand which is available to measure the smallest time is minute hand. So, the least count of this clock is 5 minutes. Similarly, the least count of a meter scale, as we have shown you, but now we have 3 meter scales differently marked. One has only one division in between, that is at 50 centimeter. So, its least count is only 50 centimeter. In next 50 centimeter are further divided into 5 divisions. So, one division is of 10 centimeter. So, its least count is 10 centimeter, and the last one scale is divided in 100 divisions. So, the least count comes equal to value of one smaller division. The smallest the least count of a measuring device, the greater is the precision in measurement. For example, the length of a given rod measured with a meter rod may give the result as 3.1 centimeter. However, the length of the same rod measured with a vernier calipers may give the result as 3.12 centimeter. Clearly, the second measurement is more precise as compared to the first measurement. Here we can show you in a table, these are the quantities measured and these are the least counts of the instruments by which they are measured. If we are measuring 400 meter, its least count will be 1 meter. If we are measuring 40.0 meter, it means up to first place of decimal, that is 0.1 meter, and so on. Limit of precision of measuring device. Every measuring device has an inherent limit of precision. The limit is determined by the least count of the device. For example, a distance measured with an ordinary meter rod is correct up to 1 millimeter or 0.1 centimeter. No matter how carefully are measured, we can never obtain a result more precise than the limit of our measuring device. The limit of precision of a measuring device is the smallest division of measurement the device is able to display. For example, a meter rod marked in millimeter has a limiting precision of plus minus 1 millimeter or 0.1 centimeter. Vernier calipers that can read to nearest 0.1 millimeter has a limiting precision of plus minus 0.01 centimeter. Similarly, diameter of the cylinder measured by a vernier calipers 3.00 centimeter lies between 3.01 centimeter and 2.90 centimeter. Now come to the accuracy and precision of instrument. Each physical quantity is measured with the help of an instrument, and the limit of the precision of the measurement is equal to the least count of the instrument. For precise measurement, we must use instrument with high degree of precision. Now we can talk about the errors. To measure any physical quantity, the given quantity is to be compared with a standard which we call unit of that quantity. No measurement is perfectly correct as the error involves in the process of the measurement which cannot be removed completely. Hence, the measured value of quantity is always different from its actual value. This difference in the actual value and the measured value is called error of measurement. The errors can be classified into the following categories, and one category is the systematic error. The error whose cause are known is systematic error. The various causes of these errors may be incorrect design or calibration of the instrument, limitation of the method used for the measurement, incorrect reading of interpretation of the instrument, lack of accuracy of the formula being used. Such errors can be minimized. Instrumental error may be due to design and manufacture of the instruments. So, zero error may exist in the instrument. This type of errors can be minimized by using more accurate instrument and applying zero correction. However, such errors cannot be eliminated altogether. There may be other limitation of the instrument also. The second category of the errors is non-systematic errors. These non-systematic errors may be the personal errors. This is due to inexperience of the observer. For example, lack of proper setting of the instrument, noting down the reading without taking proper precaution. Such errors can also be minimized by taking the observations on repetition basis. Errors due to ignorance on account of ignoring certain facts. For example, generally buoyancy is ignored at the time of weighing of a body from a common balance. Errors due to external causes arises due to change in temperature, pressure, humidity, etc. During the experiment, relevant correction can be applied to minimize these errors. Due to large variety of factors, such errors arise. The causes of such errors are not known. It is not possible to eliminate these types of errors. These errors are also called chance errors. For example, when the same observer repeats the same observation in large number of times and taking the arithmetic mean of all the observation,
Sir, you described here two type of error, that is first one systematic and second one is non-systematic.
Right, right.
So how can we minimize the non-systematic error?
Number one, to minimize the non-systematic error, because causes are not known. So, number one, observer must be the careful. Secondly, he has to take large number of observation, then by taking the mean, when we are taking the mean, we suppose that this mean will be very near to the actual value, and then we have to see the difference of every observation with this actual value or very near to the actual value, and these differences will be the error in each observation and it can be averaged. So, this we can calculate and we can minimize by taking the large number of observations. Now, same times the reading an instrument without setting the instrument properly, taking the observation wrongly without caring for the sources of errors and the precautions, recording the observations wrongly, using wrong values of the observation in calculation. So, these are certain causes in non-systematic errors. These errors can be minimized only when the observer is sincere and mentally alert in calculations and elimination of errors.
Sir, is the observation of one physical quantity associated with the different error?
Yes, very important question you have asked. When we are measuring same quantity with two different instruments, definitely the error will be the different, because their least count may be different. So, error depends upon least count also. This is systematic error, because maximum possible error in systematic errors is the least count of the instrument. So, now we can take some other examples. This type of observation can be made, but there will be error in all the instruments. Now, this error can be defined in absolute terms. In the measurement of a physical quantity, absolute error is the magnitude of the difference between the true value and the measured value of the quantity. For example, let us suppose that a physical quantity is measured n times. Let the measured value be x1, x2, x3 up to n. Then the arithmetic mean of these values is given by the sum of all these quantities divided by n, and we consider that it is very near to the actual value or true value. So, by definition, absolute error in the measured values of the quantities will be, in first observation it will be x minus x1, in second observation it will be x minus x2, similarly in third and in fourth. So, the absolute error may be positive in certain cases and it may be negative in certain cases. Now, we have to take the mean absolute error by taking the mean of all these errors, that is delta x1 plus delta x2 plus delta x3 up to n divided by n. Here delta x represents only the magnitude of absolute error. But when we state absolute error, it does not give a very significant meaning, because there are the two observers and the errors reported by these two observers is 0.2 and 0.2. But in how much observation it is 0.2? If suppose one person is committing an error by counting the note of rupees 100 and committing the error is 5, and another student is counting lakhs of rupees and making the error of 50, then definitely the second student is committing less error. So, absolute error has no significant value until and unless it is measured in terms of relative errors. So, we will talk about the relative errors. The relative error or the fractional error of measurement is defined as the ratio of mean absolute errors to the mean value of the quantity measured. Relative error or fractional error is the mean absolute error divided by mean value. Similarly, we can define the percentage error. When relative error or fractional error is expressed in percentage, then it is called percentage error, or relative error we can multiply by 100 to express it in the form of percentage error. So, relative error and percentage error are more significant as compared to the absolute error.
I want to one question. I have one question. Which one communicates the error in better way? I mean, error, relative error or percentage error?
Relative error is very much significant, but if you are expressing it in form of percentage, then it is called unification of errors, because every error is being expressed over the 100. So, this is a better way to express error in terms of percentage error.
Thank you, sir. Dear learner, so I think today we have discussed about units, fundamental units, derived units and SI units of mass, length, time, etc. Especially we have already also our expert described about precision, accuracy, error, so many type of errors. So, dear learners, I am sure you are enjoying with this video tutorial lectures, and hopefully we will get in more touch in the next video tutorial program with the rest part of unit, dimension and vectors. So, we are thankful to our experts Research Singh sir, who give their valuable time and clear about all these things about units, errors, accuracy, etc. So, dear learner, I hope you will be more benefited after seeing this video program. Thank you, sir, for coming.
Thank you, Dr. Gupta. It is my pleasure to interact with the learners of NIOS with this very unique topic, that is unit and measurement. Thank you very much.
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
सीमा से विद्यालय जो मुक्त हो, संसाधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े वे विषय के लोग